So the shape is maximum because of negative. I forgot to turn on the video. The vertex, negative b over 2a, we calculated it's 1. We plugged it in, it's negative 11. It does not have x-intercepts because the y-coordinate is a negative number. So 0, negative 12. And number 5 and number 6 are just words. Axis of symmetry for this function, please. X equals 1, axis of symmetry. And the maximum value of this function is? So max is negative 11. Can you already give us the range? And we haven't even graphed the function, but now we have a picture, clear picture in our head. What is the range of this function? I don't even have the function graphed yet. Very good. Excellent. So I'd better graph something like this. The vertex is 1, comma, negative 11. Two, 4, 6, 8, 10, 11. The axis of symmetry, x equals 1, negative 12. So here's the graph of f of x equals negative x squared plus 2x minus 12. Let's graph this function with the graphing calculator. We know that to adjust the viewing window. So here it is, plug it in y equals negative x squared plus 2x minus 12. Negative x squared plus 2x and minus 12. And go to the viewing window. You know that it has to be lower than negative 10, right, for y values. So to go to the window, negative 10, 10, I'm going to say just negative 5 or negative 4, 10, that's good enough with a scale of 2 maybe. And y minimum, definitely something like negative 30. Y maximum, I would say not more than 4 with a scale of 5. And then graph. And here it is. It crosses right here at negative 12. This is the vertex at 1. As you see, this is my unit of 2. At 1, comma, negative 11. And this is negative 12. 1, comma, negative 11. And it opens downward. It has a maximum. The axis of symmetry is right here. And you see it's a symmetric curve. You can always do this and put in the graphing calculator to double check your findings. Okay, any questions on this? Are we okay now with graphing the parabola? Okay. Now I would like to, I think I should do a couple of word problems first, and then we can look at the other shape, the other form. Okay, I'd like to look at problem 57. This is it. This is the end of chapter 11. But I need to practice, and I would like to look at word problems that have a quadratic function in them, and then graph some more. This is it. There is no more new material, actually, for the test. So the cost C in dollars of manufacture, so 57 on page 704. The cost C in dollars of manufacturing X bicycles is given by the function C of X equals 2x squared minus 800x plus 92,000. This is the cost function. Can anyone tell us what type of function is this? Of course, that's what we are talking about. It must be quadratic. Here are the questions. Find the number of bicycles that must be manufactured to minimize the cost. So I'm looking at this function. I know it's quadratic, and I know that one particular point will give us the maximum or the minimum. Which point is that?
The vertex.
The vertex. Now, can anyone tell us what does this function what will this function have? Will it have a max? Exactly. So we know that A equals 2. The function will have a minimum, and the minimum is given by the vertex. So I have to find the coordinates of the vertex. How do I find the x-coordinate of the vertex? So negative b. How much is b? Very good. Over 2 times a, which is 4. So then I have 800 divided by 4, which is 200 bikes. So that's 200. So 200 bikes, you will tell the manufacturer, listen, if you manufacture exactly 200 and you manage to sell them, because if you just put them on the shelf, it's not going to help. But if you manufacture only 200, your cost will be minimum. If you manufacture 201, will their cost be minimum? No. If you manufacture 199, will the cost be minimum? No, because we know there is always only one point at one particular x value, not more than one. So we found it at 200. So we know that we will tell him, hey, manufacture exactly 200 if you want to minimize your costs. And the question part B, find the minimum cost. How do I find the minimum cost?
200.
Exactly. So C of 200 will be the minimum cost for sure. How do I find the minimum cost? Just plug it in. 2 multiplied by 200 squared minus 800 times 200 plus 92,000. So give me the minimum cost, please.
12,000.
Say it again.
12,000.
Is it? You calculated?
Yeah.
Very good. 12,000. So 12,000 here, minimum cost. Any questions? Any questions? Okay, let's look at 88 on page 704. Methane is a gas produced by landfills, natural gas systems, and coal mining that contributes to the greenhouse effect and global warming. Projected methane emissions in the United States can be modeled by the quadratic function f of x equals negative 0.072x squared plus 1.93x plus 173.9, where f of x is the amount of methane produced in million metric tons. So the measurement unit, million metric tons. And x is the number of years after 2000. So x equals 0 represents the year 2000. According to this model, what will U.S. emissions of methane be in 2018? That's part A. What will happen in 2018? Round to 2 decimal places, they say. So I'm asked to find f of x when x equals? Very good. So this means x equals 18. So I'm asked to find f of 18. So that will be negative 0.072 times 18 squared plus 1.93 times 18 plus 173.9. So please give that to me when you have it. And then we move on to part B. How much? And it has to be in million metric tons. Okay, I'll do it myself.
I got 45.1.
Good. If two people got it, I trust you.
185.
So one,
185.
yeah. I think that's good. Part B. Will this function have a maximum or a minimum?
Minimum, a maximum, sorry.
Maximum. A equals negative 0.072, maximum. Part C. In what year will methane emissions in the US be at their maximum or minimum, since we already established a maximum? In what year will the emissions be at maximum? What do I have to find?
The vertex.
Very good, excellent. How do I find the x-coordinate of the vertex?
B.
Negative b over 2a. Negative
1.93
over
2 times
negative 0.072. Good. So please give me the year in which they will be maximum.
um, 1.3402.
I don't know. I can dig out my calculator instead of being lazy. Or I can do it over there, but it's easier with my calculator. Do we have a number for this? 1.93 divided by 2 and further divided by 0.072. I got 13.4. So which year is that?
I guess 2013.
In 2013. So here's how I got that.
I think I should my phone calculator honestly.
So we had the top, negative 1.93 in parentheses, divided by, in parentheses, 2, in parentheses, negative 0.072, close the parenthesis, close the parenthesis. And when you press enter,
You didn't put the point.
oh yes, I didn't put the point. Thank you. I did, but this calculator, I mean this software. Good. So 13.4. Good. Part D. Part D. What is the level of the emissions for that year? How do I determine the level of the emissions at that point? Very good. So I have to find f of 13.4, which is negative 0.072 times 13.4 squared plus 1.93 times 13.4 and plus 173.9. And please give me the answer.
Yeah, 186.8.
How much?
186.83.
Million metric tons. Remember the measurement unit, extremely important. Okay, very good. So the last thing we need to do is look at the other possibility. So we may be given a quadratic function that has this form. It's just presented differently. Everything is the same. The graph will be the same. The way I determine the shape, the x-intercept, the y-intercept, everything is the same. It's just that the function is given in a different form. Okay? If the function is given in this form, this will be the leading coefficient. So if it's positive, it will have a minimum. If it's negative, it will have a maximum. But the question is, which we know is the same a from the original function. But the question is, what is this little h and this little k? They represent the vertex. So there is an advantage. I'm not asking you, or I'm not suggesting that you should, if you are given the quadratic function in the first form, you should spend your time and complete the square to find the vertex. No, no, no. This is not what I'm saying. Don't do that. Because we have a straightforward way. V, the vertex, negative b over 2a, comma, f of that. But if I'm given this form, finding the vertex is slightly easier. But finding the x-intercept is more difficult. Or could be more difficult. Okay? Even the y-intercept. So let's work on this. On page 696, I would like to start with 37. 696. H of x equals x minus 6, everything squared, plus 4. We're going through the same 6 steps. Everything is the same. All questions are the same. It's just that the vertex requires less effort. That's all. So number 1, the shape. What is the shape of this function? A minimum, because a is right here, and it's positive. So a equals 1. It will have a minimum. Now number 2, the vertex is done, meaning I don't have to calculate anything. I have minus and I have minus. So when I identify h, that must be 6, and k is 4. So 6, 4. Step number 3, x-intercepts. I know how to analyze this. It has a minimum, and the minimum value of this function is 4. Therefore, should I look for the x-intercepts, or I should not waste my time? I should not waste my time because they don't exist. Step number 4, the y-intercept. How do I get the y-intercept?
Maybe 0.
For x. Good. Let's do this together. How much is 0 minus 6?
Minus 6.
Careful. Yes, of course. I'm sorry. In my head, I was already. Okay, negative 6. And negative 6 squared?
36.
And 36 plus 4? That's it. So the y-intercept is 0, 40. 2 more steps, 5 and 6. What is the axis of symmetry? And you already told me the minimum value is
4.
4. Let's graph this function. This is the only difference. The vertex is easier to calculate. Can anyone give us the range of this function, although we haven't even graphed it?
4.
Very good. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. Here's the vertex. 6, 4. Then I need the axis of symmetry, which is x equals 4. And you will have to trust me. You shouldn't at this point. Just for this little thing, I'm going to say that this is 40. You shouldn't, because obviously that's not 40. So just bear with me, and let's say that that's 40. So here's the graph. Of course, you shouldn't trust, because that's not 40. You know that. So then f of x equals x minus 6, everything squared, plus 4. So that's the only difference. Just the vertex is easier to calculate. Okay, I would like to look at one more and then show you a couple of things here. Yes, let's look at 47. Any questions? In 47, we have h of x, negative x minus 1, everything squared, minus 1. Everything the same? So part A, shape, what will it be?
Maximum.
Good, because the leading coefficient is negative 1. B, now you can give me the vertex right away. Very good, excellent. And then C, x-intercepts, if they exist. Analyze and tell me if they exist, because if they don't, I don't want to waste my time. They do? The maximum value is a negative number. Do they exist?
No.
No, none. Part D, axis of symmetry. I'm sorry, I forgot, y-intercept. How do I get the y-intercept?
Make it 0.
For x, h of 0. How much is 0 minus 1? Negative 1 squared. With a negative in front.
Negative 1.
Negative 1 minus 1.
So 2.
So 0 comma negative 2. And E and F, just words. What is the axis of symmetry?
Negative 1.
And what is the maximum? And now you can give me the range without even graphing it, because you know how it looks like.
Negative 1 to negative infinity.
Yes, you're right, but negative infinity to negative 1.
Yes.
Good. So let's graph the function. And I forgot, I really wanted to show you one more graph with the graphing calculator. So I have to graph the vertex first, 1 comma negative 1. Then the axis of symmetry, which is x equals 1, and 0 comma negative 2. And just graph the function. And this is f of x equals negative x minus 1 squared minus 1. Any questions on this? As you've noticed, we went through exactly the same steps. The only thing is that this... Now, I just want you to identify the vertex on a couple of problems. So let's say I have f of x, negative 3, x plus 4 squared, plus 8. I just want you to identify the vertex for me.
Negative 4 and 8.
Very good. Do you all agree with negative 4 comma 8?
Why is it negative?
Because the formula has x minus h. Okay, let's say 2 more, or at least 1 more. Let's say f of x equals x plus 1 squared minus 7. Can anyone identify the vertex for us?
Negative 1 and negative 7.
That's it. Very good. Now I just have for a couple of minutes before we start practicing and reviewing for this test a week from today. So let me write this down for you. So test 3, Wednesday. Today's the 2nd plus 7, it's 9. I just want to walk you through what we call transformations. You don't have to write that down right now. I will at the end. Let's suppose I want to graph f of x, which is x squared. The simplest possible quadratic function. How will I graph it? First of all, does it have a minimum or a maximum?
A minimum.
Minimum. Good. It has a minimum. It opens upward. And what is the vertex?
0, 0.
Right. The vertex is at the origin. Excellent. So this is the graph of x squared. Now what do you think will happen when I want to graph the function f1, which is x plus 2 everything squared. Don't say anything just yet. This is 0 when x is 0. Where will this be 0? Where will the function be 0? When x is? Right. So I know where this graph is going. I know you will be tempted to say it's going to the right 2 units. But since the x-intercept is where again? At where x equals -2, this is a left shift of 2 units. So the same function, but now it turns here at -2. And this is x plus 2 squared. What if I want to, now I want to graph f2, which is x minus 3 squared. So just tell me, where is this 0 for x equals 3? That's why 1, 2, 3. And this is x minus 3 everything squared. So these are called horizontal shifts when I change x. Okay. Now I come back to the same function. This is done. This is another question now. I still have f of x, which is x squared, and which is this function, as we know, the simplest possible quadratic function. But now I have 2 questions, different than before. I want f1 to be x squared plus 3, and I want f2 to be x squared minus 4. Exactly. Notice that y value, the x value don't change. Here, I had x inside, and it changed to x plus 2, so that's why this is a shift in x. Here, I have x squared and x squared. X does not change. Something else changes. Y. So this is up 3, and this is down 4. So up 3 will look like this. So this will be x squared plus 3. And down 4 will be this. So what type of transformation is this?
Vertical?
Up and down shift. Or vertical, you're right. We're changing x. Any questions so far? Okay. So I'm going to call this horizontal shift. This was of 2 to the left, and this was of 3 to the right. I'm going to call this a vertical shift. This was up 3, this was down 4. Okay. 17, that's my page number. Okay, now I start with the same function, the simplest possible function, but I would like to graph f1, which is negative x squared.
Don't you make it a maximum now?
Exactly. So the original function, what we call the base function, is this, which is x squared. And how do I graph negative x squared? Very good. Any questions? Okay, what is this called? A reflection. Reflection with respect to the
X-axis.
very good. Excellent. Reflection with respect to the x-axis. So now, I would like to give the following example. F of x equals negative x plus 1 squared minus 3. Can anyone give us the transformations? These are all called transformations. The transformations on x squared. The first step, it has to be in the order of operations.
So it's gonna be a maximum.
So first of all, the first transformation will be x plus 1 squared. Where will the graph go? Left one. Number 2. So I perform the left one. Now I have to multiply by negative 1. So negative x plus 1 squared. What will this do to this graph? Flip it. Reflect with respect to the x-axis. Finally, number 3. Negative x plus 1 squared and minus 3. This is a transformation exactly on this. So it's down 3. That's why the vertex is that's it. I know that. I know why. It moves to the left, right? 1. Then it flips and then goes down. So that's why the vertex is negative 1, comma, negative 3. Is this better? Any questions? Yes. Yes.
Like the ones that we've just been doing, like the parabolas and stuff, when you put those on the test, is it going to be like how you did that workflow, kind of like A, B, C, D, E?
For the graph? No, I'm just going to say, don't forget to graph using la 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 and show whatever. Yeah. Any questions? This is it. This is the end of chapter 11. There is nothing else that I can teach you here. You know as much as I do from this chapter. I wanted to, I forgot to go over the previous lecture, and if anybody wants it, you can have it. I forgot to do that at the beginning. I'm sorry about that.
Can I have?
Yes. Yes.
Let's see.
So the last one was Monday, right?
Yes.
The 31st. Okay, here it is. So last time we looked at more factoring and substitution, and then chapter 11 with more factoring, substitution, solving equations, and solving more equations, and substituting and getting 4 solutions, and then more equations. And this was one of the your questions today. Same thing, same problem. So this was the problem that we just looked at again. We said that there are 4 methods of solving quadratic equations: by factoring, taking square roots, completing the square, and quadratic formula. And we looked at completing the square. These are the 4 steps in completing the square. So we completed the square, and I said it's a kind of a useless method for quadratic equations, but we need to know it because it's useful later. But we know that complete the square does not alone solve any equation. We need to use taking square roots. When the leading coefficient is not 1, we have to make it 1 before we complete the square. And then we looked at the quadratic formula. And remember, now you know that this alone, negative b over 2a, is the x-coordinate of the vertex. So we got solutions for quadratic formula. Here we got imaginary solutions. Then we talked about the discriminant. And now we know when the discriminant is 0, actually I will find 2 distinct solutions. When it's 0, I will find 1 real solution. And when it's negative, no solutions. And then we looked at the word problem. And we determined the base and the height. And this was today. And that's it. Thank you. Thank you. Okay, I'd like to start reviewing for this test a week from today. What would you like me to start with? Excellent. So let's complete the square. So please, if you have your book, I'm looking at the review problems. Between now and Monday, I highly recommend do problems 1 through 71, pages 708 and 709, and you will be super prepared for the test. Super prepared. You do not have to do problem 70. I'm sorry. No 70. We cannot do that just yet. And also, forgive me, and also 39 and 40. You should not. No, we have not discussed this yet. So these 4 problems you cannot do. So 32, 39, 40, and 70. You cannot do those yet. Okay, so we want to complete the square. Let's say problem 5. 5 is on complete the square. Z squared plus 3z plus 1 equals 0. Sure. Now, before we start talking about this, let me think for a second. Today is the 2nd, right? Yes. Today is the 2nd, isn't it?
Yes.
Then we have the 7th and the 9th. And then we have the 14th and the 16th, right? And then we have the 21st and the 23rd. And we do meet on the 23rd because school closes at 4. And then the 28th and 30th. Right? So if our test 3 is here, 1, 2, 3, 4, 5. Okay, 5 will be enough. And then we'll have test 4 here. And then we are in December. I have to look at my phone. I'm sorry. No, it's not 18th. It's 9th. It's on the syllabus.
Don't have 9 days this semester.
No, I thought you said when it ends.
Yeah.
On December the 9th. Yeah.
When's our test? It's on the syllabus.
So right here. So the 9th test 3. And then 1, 2, 3, 4, 5, 6. And then the 5th and the 7th. And that's it. So on December the 5th and December the 7th review. For the review. Final exam. Okay? So here's the schedule. We are going to review here again. I'm going to continue to review for test 3. And then 14, 16, 21st, 23rd, 28th, I have to finish the last module here for test 4. We're going to have to review here. And then test 4 on the 30th. Ready? Okay, we're completing the square. We're starting the review. Completing the square, please. Please, ladies and gentlemen, do we have an answer for number 5?